Okay, students, a couple of things. I've uploaded a solution guide to 3.3, and I've also created a Google Sheets, it's all in the same folder, called Postulates, Theorems, and Definitions. And I want you to make sure that you download both of these. You don't have to download this into Notability. You can access this from the drive and just call it up. But of course, the solution guide I want you to call up into Notability so that you can compare notes with the 3-3 sheet that you did over the last 2 or 3 days, school days that we had. Okay, but this new sheet you can just open up in Drive. I don't know how well it would import into Notability. I don't think it would. So just open up into Drive, and in the Drive this will open up as what we call a sheet. But this is not all of the theorems and postulates we use, but most of them, and certainly all the ones that we're going to need for today's example. Okay, and the names are on the left if you look at this sheet now. So pause this video and make sure you get to this sheet, and then start the video again. Okay, so you should see all of the yellow and blue. And these are the if and then statements of each of these theorems or postulates or definitions. And we're going to be referring to this sheet as I solve a proof. So we're going to do problem 9 from 3-3, and I'm going to walk you through how to do it. Hopefully you've already given it a try. Maybe Mr. DPR has already gone over it with you. But I'm going to show you how I would approach the proof and how to do a proof you've never seen before, which is what honor students should be able to do. And we're going to use these yellow and blue columns, the if-then statements of each theorem or postulate or definition, to help us figure out which one to use. All right, so let's go to this proof. This is number 9. If you've already done it, that's fine. You can just kind of follow along. If you haven't done it, you can do it as I do it while you're watching the video. Of course, pause the video at any time to look at the documents that I'm referring to. Another good idea would be, in addition to doing this during class, to watch the video at home on your PC and then have this file open on your iPad. And if you have 2 monitors or a large monitor, you could have this Google Sheet open too. So how you want to do that is up to you. All right, but if you just watch the video, you're going to learn a lot. Then you could try it again on your own, which is what I always recommend you do before the test. Many of you did not even get the vertical angle theorem problem correct on the last test, and that we had given you the solution to in class. So you have to at least memorize the proofs that we've given you the solutions to, because very often they will appear in the test. Okay, let's do proof number 9. Again, one of the things we talked about is working from the bottom. So I see here that I need to prove that segment ED is parallel to AC. This segment ED, and again, bring in highlighters in your test. Use highlighters now in Notability. ED is parallel to AC. So I'm going to work backwards a little bit. So I'm going to actually take this and move it to the bottom. I may not use line number 11, but it's okay. And the big question is, of course, what is this going to be, right? What is the reason going to be? But we're going to work backwards a little bit. So if I was to prove that 2 lines were parallel, I would need to go to my worksheet here that I've created for you with all my theorems, and I'd have to look at the blue column, and I'm looking for something that says, then the lines are parallel, okay? So if I go back to this sheet here and I scroll down, I'm looking for anything in this blue column that says, then the lines are parallel. Why? Because that's what I'm trying to prove in statement 11 here. I'm trying to prove, if you look at the screen here, 2 lines are parallel. So I need something that says, if something, which I don't know yet, that would be statement 10, then these 2 lines are parallel. Right? So let's look over here in this column for anything that says, then 2 lines are parallel. These don't, these don't, these don't. Bingo, here we go, then 2 lines are parallel. So it could be any one of these 4 theorems or postulates. So it's the converse of corresponding angle postulate, the converse of alternate interior, the converse of alternate exterior, the converse of same set interior. I actually put these in the order that they're most likely to happen, although I think maybe the second one is more, line 17 is most likely to happen, but these 2 are the most common up here, and the other 2 are not so common. So it's probably going to be 16 or 17. Let's take a look. So if we look to our diagram here, ED and AC, ED and AC only have two angles associated with them, this angle 4 and this angle 3. And if you look, these are alternate interior angles, right? So to prove these two lines parallel, these ED, the segments I should say, ED and AC, to prove them parallel, I'm going to need to prove that the alternate interior angles are parallel first. So that is going to be right here, right? So I'm not going to, unfortunately I don't have access to all my tools, so I'm going to use these wrong angle symbols. Please use the ones you see up here, right? But that's all I have at the hospital here. So angle 3, and it's going to be congruent, which I also probably could paste in, but I probably can't right now. It's going to be congruent. So put the congruent symbol, not this, to angle 4. How do I know that? They're the only two angles that are interacting really with these two parallel lines. And I'm looking here, these are the only 4 theorems or postulates that make that happen. So it's going to be 17. The converse of alternate interior angles theorem. What does it say? It says if two alternate interior angles are congruent, so in other words, if 3 and 4 are congruent, then these lines are parallel. Now we haven't proven it yet, right? We haven't proven it yet, but it's just a hunch that that's my goal, to prove that angle 3 is congruent to angle 4. So right here where this question mark is, I kind of already know it's going to be converse of alternate interior angle theorem. And of course, you can always abbreviate the way I do here, okay? Okay, and of course, for that to be true, then angle 3 would have to be congruent to angle 4, because this says, right, this theorem right here, this line 17 says, right here, if two alternate interior angles are congruent, there's the if. Remember, the if has to appear on a previous line, it does. Then the two lines are parallel, then this. So if this, then this. So this theorem or postulate, in this case the theorem, should say theorem. So this theorem says if this, then this. Okay, and it's right here, and that's how we use these yellow and blues to help us kind of give ourselves a target here. So we now know that our target is angle 3 is congruent to angle 4, so I have to somehow work with angle 3 and angle 4. Well, I already know angle 4 is 30, so something with these other givens are going to lead me there. All right, that's all I'm going to do from working from the bottom. Now let's work from the top. I'm given 4 givens, okay? Anytime somebody says, oh, something is this, right? In this case, a right angle, or supplementary angles, or an angle bisector. Anytime somebody declares something to have a name, I know it's a definition. So I'm going to look to my definitions to see which definition says the word right angle in it, right? So I'm going to scroll down to my definitions here. Which of these, and these are not all of them, but they're most of them that we use. And again, this triangle sum theorem should be under theorems, but it's okay. It's under here for now. But anyway, which of these says if it's a right angle? There it is, right there. I look in the yellow. If an angle is a right angle, did that get said? Yes, it got said right here. So then I know I'm going to write this. The measure of the angle is 90. Okay, I know that now. So I know that the next thing I want to write is the measure of the angle. Again, do not use this symbol. It's just that I'm in a hospital. I don't have access to the other symbol easily enough. So I need to write the measure of angle ABC equals 90 degrees. Okay? So now I have angle 2. I have angle ABC, but I don't have any information about angle 3 here. You see? But I am told another important fact. I'm told right here in line 4 that these two lines are parallel. What does that mean? That means I have to go to my yellow, because this is given information, and look for something that says if two lines are parallel. Okay, so if I scroll up and down through my theorems and postulates, here are the 4 things that say if two lines are parallel. Okay, there's actually another one too. There's the two lines parallel theorem. But for the most part, we're going to be using these. So I didn't make a complete postulate theorem definition sheet here. You can add a couple on your own if you'd like. But the most common ones. So it's going to be one of these 4. So I'm saying which of these 4, even though it's probably the first 2, it usually is, which of these 4 am I going to use? In other words, which of these 4 do these parallel lines, AD and BC, segment AD and segment BC, parallel segments, which of these parallel segments are going to lead me to some angles congruent, right? So let's take a look, or supplementary. So AD is parallel to BC, right there. Well, the only angles interacting with those two are 1 and 3. Those are alternate interior angles, right? So I know it's going to be this one, the alternate interior angle theorem. I know it's not the converse of alternate interior angle theorem because that doesn't start with if two lines are parallel. But I know that this one does start with if two lines are parallel. Then this, the two alternate interior angles are congruent. By the way, if you want to see different version, if you click on this little tab down here, you'll actually see examples, which may help you more. And there's actually a chart over here. So if you want to switch between these two, you might find one more useful than the other. Okay, but this is the formal version here. So these two lines being parallel, this line 4 is going to give us or lead us to the conclusion, right, the then of the alternate interior angle theorem, which says that angle 1 must be congruent to angle 3. Okay, good, so let's write that. And by the way, I could have put this in line 5. It didn't have to go here. I'm kind of jumping around a little bit. Angle 1 is congruent. Again, use the congruent symbol. Do not use what I'm writing here, but I'm stuck at a place where I only have a Macintosh, so I apologize. Angle 1 is congruent to angle 3. Why is that true? Well, that's what this line 4 led me to believe. See, led me to believe this. Because it said these two lines are parallel right here. AC, I'm sorry, not AC, AD and BC are parallel, which means these alternate interior angles right here are congruent. So this is the alternate interior angle theorem, not the converse. And by the way, I forgot to put over here definition. We talked about it, I didn't write it. Definition of a right angle. Okay, so we've got this and we've got this, right? But we have all these measures here, and we're trying to get angle 1, and we're actually trying to find angle 3 because that's our target right here on statement 10. Statement 10 shows us our target. Statement 10 shows target. So we're trying to get angle 3. We don't know anything about angle 3. But we found this congruency statement here. Unfortunately, these are measures, and that's congruency. So we're going to have to manipulate this a little bit and say that the measure of angle 1 is equal to the measure of angle 3. Again, use the proper angle symbols, not these. Use these symbols here, not these. Okay? And that came right out of this statement here, and that's just definition of congruency. It's how you go back and forth between congruency and measures are equal. By the way, we should be putting some reference numbers here. I haven't done it, so I'm going to put 6 for this one. The alternate interior angle theorem came from line 4, if you remember, so I'm going to put that reference number here. Sorry. And this one came from the fact that it was a right angle. That was from line 1. So I'm going to put the reference number here. Again, put your reference numbers at the end. It's just that I'm working here in difficult conditions, so I am not going to make it as neat as I normally would. Okay? All right, so 1 is the same as 3, but that's still not really going to help me, right? It's really not going to help me yet because I know about angle 2, and I know about this angle is a right angle. It's 90 degrees. So angle 2 and angle 1 and angle ABC here are related because they're all part of a triangle, right? So I'm going to use triangle sum theorem, which says the measure of angle 1 plus, measure of angle 1. Again, use the angle symbols, don't use my symbol here. Measure of angle 2 plus the measure of angle ABC equals 180. That's triangle sum theorem. You can look it up on the chart. And then I'm going to substitute all my values in here, right? I'm going to substitute all my values in here. I think what's going to happen is I'm going to actually run out of lines here, so I'm going to have to change some stuff. But I'm going to sub in some things. So I want to sub in measure of angle 3, because I know 1 and 3 are the same. I'm going to put in the value for angle 2. That's 60 degrees. Okay, I can't put a degree symbol here from my Mac, apologize. And the measure of angle ABC, which was 90 degrees, equals 180. Okay, and that was substitution. It was actually substitution times 3. I believe we did 3 substitutions. Okay, so the reference and triangle sum theorem, by the way, comes from D. It's one of our D theorems, which is really nice. That's why I got to move it back to that other section. So it's really in a bad place here. I got to move it up to the top. Triangle sum theorem here. This is D. I need to move it way to the top up here, and I'll do that another time for you. But you can do it on your own. Okay, and then we subbed from a lot of places, right? So we took line 8, and then we subbed in information from line 7, from line 5, and also from line 2. No, sorry, from line 3. Okay, now the problem is we're not ready to go right here. We have to find out what angle 3 is by doing some subtraction property of equality. So I'm going to have to insert some lines in here, which I don't know if I can do in the software. I'm sure I can, but yeah, table. Maybe not. I hope I can. Oh, add row above. Okay, I'm going to do that again. Format table. Add row above. Format table. Add row above. So apologies that we ran out of lines here. And again, notice that I can change my line numbers here, and you can do the same thing in Notability. So in Notability, all I would do is, at the bottom of the proof here, I would just add lines, just add line numbers here, and just write them underneath here. You don't have to be really fancy about it, okay? All right, so what I'm going to do is I'm going to subtract 90 and 60 from both sides, and that's going to leave me 30. So I'm going to get measure of angle 3 equals 30, and I just did subtraction property of equality, subtraction prop of equality, and I used line 9. Basically, that's all I did. And now I know that 3 is 30, and if from step 2 I know that 4 is 30, so I can do a little transitive or substitution, either one is correct, and put angle 3, the measure of angle 3, is equal to the measure of angle 4. All I did was transitive, or sub. You don't have to write that, but I'm going to write it for you that you could use either one, transitive sub. And of course I got that from line 10, the line that I just used. So I got that from line 10. And I also got it from line 2, because that was equal to 30, and the measure of angle 3 was equal to 30, so that therefore they have to be equal to each other. So I really should put 2, 10 for my line numbers. Again, my line numbers should be way over here. I'm not going to have a time to do that because I'm really in a tight place here, so you can envision that on your own and fix it up. So this should have a nice little column here for reference numbers, and you should put them all in that column. Okay, so now that we know that the measures are equal, that means that they're congruent. That's just definition of congruency again. Remember, that was our goal to get here. That gave me a target to know that I've got to figure stuff out about angle 3, which was all this work here. All of this work here was to figure out stuff about angle 3. I used triangle sum theorem. I used the parallel lines. I used the angles that they gave me, the angle measures that they gave me, and I did all that work. So line 12 is useless, so just you can put a line through it or put NA, and that's okay, particularly when we have a long proof like this, an honors proof, and we're doing a lot of work. Okay, definition of congruency here, this of course comes from line 11, and converse of alternate interior angles comes from line 13. Okay, so practice this proof on your own, watch the video again. I'm also posting solutions to most of the proofs from the 3-3 pack. So check your answers and practice them again, and then good luck. Mr. DiPiero will be in after school for extra help today, so stay for extra help and do some more practice proofs with him as well. Good luck.